Hello everyone, this is Mr. Appel, and today we're going to talk about points, lines, and planes, and just how to talk about them in geometry and all kinds of good stuff like that. So let's get started. First of all, the terms points, lines, and planes are, a point, a line, and a plane. If you think about a point, you know what a point is, but if I ask you to actually define it, it's very, very difficult. It's really not possible to define it in a way that really makes sense. It's kind of a dot. It's a single spot in space, but it's very difficult to define. Similar with a line. A line, you know what it looks like when you see one. It goes on and on forever in both directions. It should have arrows on both ends. It's straight, whatever that means. A line has to be straight. You know what a plane is? A plane is a flat surface, goes on and on forever in all directions, but very difficult to define. So in geometry, formally, we consider them the undefined terms in geometry. We just accept their meanings, and when we do that, we can define just about everything else in geometry based on those three terms. Okay, so let's kind of take those a step further. Collinear points. So collinear points are points, they want to be very clear about this, they are points for which there exists a line that passes through them. So if I asked you if points A and B in this figure are collinear, you might think no, because there isn't a line drawn that passes through them. But they are in fact collinear, and the reason we say they are collinear is because you can draw a line that passes through them. There exists a line that passes through them. So that means they're collinear. Now, if I asked you, what if I added in a third point? Let's say I added in point C. So are those 3 points collinear? Well, if there exists a line that passes through them, which there is, they are collinear. But do 3 points have to be collinear? Well, no. What if I moved point C over here? Now if I said, are points A, B, and C collinear? You would say no, because there's no way you can draw a line that passes through all 3. You can draw a line that passes through A and C, or A and B, or B and C, but not all 3. Okay. Coplanar points, kind of the same concept. Does there exist a plane, a flat space, that contains those 3 points? So let's say let's use those same points A and B, and C. So does there exist a plane that contains those 3 points? Well, the answer there is yes, and you can see that my screen is flat, and all 3 of those points are in that screen. Now, if I add a 4th point, like this one, are those 4 points coplanar? Well, right now they are, because they're all on the same plane. I'm going to show you a little animation here and see if this can help illustrate what can happen. So there's 3 points, and see they're floating around, and you see that no matter where they go, there's a flat surface that can go through all 3 points. But now watch what happens when I add a 4th point not on that plane. Notice now those 4 points are not all on the same plane. There is not one plane that contains all 4 of those points. So 4 points are not necessarily coplanar. 3 always are, 4 not necessarily. Now, can 4 points be coplanar? Sure they can. I'll show you what that looks like. You could have 4, 5, 6, 10, millions of infinitely many points that are all coplanar, but they don't have to be. And that's kind of an important concept that we'll get into in class. So if you still kind of have some questions about that, we'll definitely address it in class. But now let's take a look at some vocabulary and just some of the ways that we name things in geometry. And we're going to look at it in the context of the intersection of figures. The intersection of figures. And the intersection of 2 figures is simply all the points, the set of all the points that are in both figures. And there's a lot of different ways we can talk about that. And there's a lot of different notation in this figure that I just want to point out. And again, we'll get into it more deeply in class. When you name a plane, for example, you can name a plane using a capital letter. So in this figure, that green plane, that green flat surface that we're imagining goes on and on forever, is called M, capital M. So you can use a capital letter to represent a plane, so plane M. Now this is where it gets confusing, because point P, you see that P is associated, you see how it's right next to that point there? So P, you can assume, is referring to that point, that dot. And so P is not the plane, it's just that point P. So we also use capital letters to represent a point. And you should actually see a point there for that to be the case. Okay. Then we have some lines in this figure. I see line K. You see line K is in plane M. It's on the plane. You see that it's black right on the plane. Notice, though, that line J is sort of a 3D line, and it's passing through point P. And you see those little dashed lines. That's what tells you that that line is actually going sort of through the plane. It's going through the paper. So that dashed line shows you that that's part of the line that you can't actually see. And that's an important thing to look for in figures. That shows you that it's 3D and it's not all flat. And some of the ways we can talk about that, we could say that line K and point P are in M. Point P is the intersection of line J and plane M. That's what this last one says. So don't get too worried about all that language. We'll talk more about that in class as you work through problems in class. Okay, here we have two planes intersecting. So we have plane M, which is the dark green one, and we have plane N, which is that lighter green one. Then we have points X and Y that are on the intersection of those two planes. Again, we'll get into that a little bit more in the work that we do together later in the period. So let's just look at this figure to do a little visualization, and then we'll get to work. So try to visualize three-dimensionally what's going on here. And so you'll notice, for example, that point A, right there, point A is actually in the man's pocket. So you can picture where that is. Point C, or ball C, we're using tennis balls to represent the points. She's hitting that ball, so that's up in the air above the ground. The other balls that are labeled, B, F, E, D, and G, those balls are all sitting on the ground. So those are all on the plane of the tennis court. And so I'm going to ask you some questions about that, and then we'll move on. Hope you enjoyed this, and we'll see you next time. Thanks.